This is video 2.8.1, and the goal of this video is to understand how to solve problems involving direct and inverse variation. So the best way, you're going to have to memorize some of the language that's used here. It's a common language to describe situations. And the first thing that we're going to look at is direct variation. A situation can be described by direct variation when it's a linear function, y equals kx. Okay? We say this varies directly because really you're just saying every time to get y, you just multiply x by something. This will describe all proportional situations out there. Another type of variation is direct variation with powers. So this is when variable varies directly as a certain power of the function. And in this case, so we're going to look at y equals kx to the n. So k is a number in both of these cases. It's a multiplier, and that's the number you'll have to find for the different problems. The question, they'll give you some data, and they'll tell you it varies directly, and you have to decide what k is, okay? And they'll give you n as well, okay? So we're going to use the information in order to find the variable, the missing k value, the variation that it has. A couple of key things here are the things that are in bold. So you probably want to write that down and or memorize it, or know that it's in your textbook if you forget. So knowing that this language right here is often how it'll be talked about in your book, okay? Or this language here, and that's going to help me decipher who's y, who's x in this direct variation equation. So let's take a look at example 1 to make sense of that. So in example 1, it says the volume of a sphere varies directly as the cube of the radius. So I'm seeing a direct variation. So I know it's one of these two equations that we see here. But I also see that it varies directly as the cube. So when I see this word cube, I'm thinking that it's going to have a power. Okay, so I'm going to have a power of 3. So far I know my equations, y equals kx to the n. Y equals kx to the n. And n is going to be 3 because it varies directly as the cube of the radius. So I'm also seeing the word radius where x is in this statement. So radius is representing x. So I'm going to change this even further and change it to r cubed. And then I also see that the volume is the one that varies directly. So volume is my y value. So I'm going to use variables that make sense to my problem. So right now I have the following equation, and it looks like the only thing I'm missing is k in order to write the equation for the problem so I can solve future problems. So let's see. The way I'm going to find k is by plugging in the numbers I know. I know the volume is 523, so I'm plugging in 523.6 for volume. When the radius, so I don't know k, but I know the radius is 5. So 5 to the third. Now I can solve for k. Okay, so using the 1 point they give me, I can figure out what the variation is, what k is. So it looks like 5 to the third is 125. So I'll divide both sides by 125. And my answer for k is 523.6 divided by 125. I'm not going to round this or change this because I want to be able to find exact values as best as possible. So I'm going to leave it as this weird fraction. 523.6 divided by 125 times r to the third. This is my function for the volume of a sphere, the volume of a sphere. So now the question is asking, what is the radius when the volume is 33.5 cubic inches? So my question mark is, what is the radius when I know the volume? So now I'm going to plug in for the radius. I'm going to plug in for the volume because they told me the volume is 33.5. And I'm going to solve for the radius. So really important to know what your variables represent and to use letters that make sense. So it looks like I'll get this by multiplying both sides by 125 over 523.6. And it looks like when I do that math, I'm going to do it to both sides, so it'll cancel over here. I'll get 7.997 equals r to the third. I'm looking for the radius, not the radius cubed, so I need to take the cubic root of both sides. Remember, there's a key in your calculator to help you with that. The cubic root of 7.997 is approximately 2. And that'll be my radius. And think about it, 2 times 2 times 2 is about 8. Okay, so this is all, if I round it to the nearest inch, it's 2. Okay, so just to pinpoint some of the key things here that you want to keep in mind. It's important to understand the lingo and who is X and who is Y. Who is dependent on who. So what's really important is that you understand how this helps you decide who Y and X is when you see the real life problem, okay? Because last time we saw that the volume varied directly as the cube of the radius. And that helped us decide that volume was Y, radius was X, and 3 was the power. So that's really important that you understand those two phrases. And the same thing goes for inverse variation. So let's take a look at the next example. Inverse variation is described by an equation in the form y equals k over x. So this is a rational function, remember. It's going to be it's going to have asymptotes, and it's going to have a limit, and so on. So when we have this, we have a similar language. Thankfully, it's similar, but it's going to have inversely instead of directly. And so when it's inversely, we know we're going to have to create a fraction, k over x. So once again, k is that number you're trying to find. So let's take a look at this example here. So we have the pressure P of a gas in a spray container varies inversely as the volume V of the container. So P, the key things here are that P varies inversely as the volume V of the container. So that tells me that P equals K over V. Because it's identical in statement to this statement, where P is Y and V is X. And K is something I don't know, and that's what I'm going to find from this one piece of information. I see that the pressure is 6 when the volume is 4. And then they want me to find what happens when the pressure is down to 3. So let's take a look and plug these into what we know. We know the pressure is 6, and that gives me a volume of 4. So I'm going to solve for K by multiplying both sides by 4, and I get 24 equals K, and that's my variation, my constant variable, the thing that's going to vary. So how much it varies by, there we go, that's what I want to say. So 24, that's my official equation for this particular bottle of spray container, this gas in the bottle. So now the question is, what is the volume when the pressure is down to 3? So now I'm going to use my equation that I have. I'm going to plug in for the pressure, so 3 equals 24 over V. So what happens to the volume when the pressure is down? So it looks like I'm going to have to solve the proportion, so 3V equals 24, and it looks like V will be 8. So the volume is at 8 when the pressure is down to 3. Okay, have you ever noticed that in a spray container when you are, over time, as you get less volume in that spray container, whether it be hairspray or it be a cleaning fluid, the pressure builds up and it shoots out with more power, and that's an inverse variation. So our answer here is 8, and once again, the key things here are what you see in yellow. It's knowing what is what, who is X, who is Y, and then finding that constant K, the constant of variation. Here's your checkpoints. 2 questions. So you have to decide, is it inverse or is it direct variation? What equation to use of the 3 that you saw? And then answer question 2 using your own various logic. So bring in your questions to class, and we will be practicing this on Monday.